Hi, this is Professor Mary Ann Barber. Example, $3,000 is deposited into an account that pays an APR of 7.2% compounded annually. How long will it take for the balance to reach $150,000? To solve finance problems, it's best to have a plan. My plan is to first identify the formula. The problem says compounded annually. Furthermore, it is a one-time deposit. So this tells us we're going to use the compound interest formula, which is A equals P times 1 plus APR over N, all to the power of N times Y. After the formula is identified, then let's identify the parts. So identify parts, or in this instance, variables. A is the account balance, and the problem statement says the goal is to reach $150,000. P is the present value. It is also called the principal, and the principal that's deposited is $3,000. We have several more variables. The APR is given as 7.2%. In these finance formulas, the percentages need to be expressed in decimal form, so that'll be 0.072. And then we have one more piece of information, and that is the frequency of compounding, which is the variable N. Annually means one time per year. So the problem asks us to solve for how long it's going to take, so we are solving for the Y. We've identified the formula, identified parts. Next, let's complete the formula with the values. So we're going to put this together. We will have 150,000 is equal to principal of 3,000 times 1 plus the APR of 0.072 divided by 1. It is compounded annually to the power of 1 times, and the unknown is in the exponent. Now we solve. The first thing I would recommend in solving this problem is to divide by 3,000 on both sides. So, when you divide by 3,000 on both sides, the left-hand expression 150,000 divided by 3,000 becomes 50. Order of operations instructs us to perform computations inside parentheses first. So, this becomes 1.072, and 1 times y is just y. Now, the trick is we have to know to take the natural log to solve for an unknown in the exponent. So let's take the natural log, ln, of both sides. So we have ln of 50 is equal to the ln of 1.072 raised to the power of y. There is a special property of logarithms that permit us to move the exponent into the coefficient. So now we will write this as ln of 50 equals y times the ln of 1.072. Continuing, now we need to solve for the y. So copying again what was on the previous slide, we have ln of 50 is equal to y times the ln of 1.072. Let's divide by the ln of 1.072 on both sides. So the ln, or the natural log of 50, divided by the natural log of 1.072 equals y. Use your calculator to compute the values. Push ln 50 and then write the full expanse of the digits you see in your calculator. So in this instance, I got 3.912023005 for the ln of 50. And then for the ln of 1.072, 0.0695266063. It is very important that you do not cut off, round up, round off, or even truncate during computation. Now perform the division and we get 56.267. The instructions state round up to the next full year, and so the next full year will be 57 years.